Hi everyone, in today's lesson we're going to talk about exponential regression day 2. So the first thing that I want to talk about is what does an exponential graph look like? You should recognize this from earlier on in the year. This is an exponential growth and this one's an exponential decay. So if you can see, I've drawn in a line of best fit for both of those exponential growth and decays. So basically, an exponential regression is a scatter plot that takes the form of exponential decay or exponential growth. It kind of works the same thing as we did yesterday with linear regression. So let's go through an example together. So example number 1 says, the data at the right shows the cooling temperatures of a freshly brewed cup of coffee after it's poured from the brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. Part A says, determine an exponential regression equation model for this data, rounding all values to the nearest 10,000th. So 10,000th is about 4 decimal places, so keep that in the back of your head. So for now, like we did before, go to your stat and go to your edit and put in list 1 and list 2. I don't know why I just switched those. So this is list 1 and this is list 2. So for purposes of time, I've already put my data values in. So hit stat and then edit and type your numbers in. I suggest at this point you pause the video, carefully put your numbers in because there's a lot of room for error here. Double check it, and then once you feel like your numbers are perfect, you can hit resume for the rest of the explanation. Okay, so once your data values are in, you just have to hit second quit, so you're back to the original screen, and then you want to hit stat, and you want to go over to calc, and instead of choice 4 for linear regression, we're going to do exponential regression, which is 0. And the same thing as before, our X list is our list 1, so we hit second 1 to get L1, and then we hit second 2 to get L2, and we don't need anything in our frequency list, and we don't need anything in the store regression, and we just hit calculate. So this is our information. So it's in the form now, y equals a. That little star means times, so you can go ahead and put the b in parentheses for multiplication. So a times b, that little caret, means to the x power. And it says round all values to the nearest 10,000th, which is 4 decimal places. So the a is 171.4617, that's 4 places. B is 0.9882 to the x power. So this is our exponential regression equation. And again, if you look at the R in this case is about 0.98. We could just say about 9.8 if you want to, for rounding purposes. So it's a pretty good fit for correlation. So let's see how we can use this information to answer a couple of questions. So I've already kept the formula for us. This is our formula that we're using. And let's see what I'm asking. So question number 1 says, using the exponential regression equation found in part A, which I wrote down here, predict the temperature to the nearest whole number at the end of 1 hour. So let's go back. Temperature is our x value. Temperature is our y value, where time is our x value. With any equation or table of values, this is always your x values and this is always your y. So the temperature is y, so predict the temperature y when the time is 1 hour. And again, if you look back over here, the time is in minutes. So we can't just put in 1 for hours. We're going to have to put in 60 for 1 hour, which is 60 minutes. So y equals 171.4617 times 0.9882 to the 60. So let's clear our calculator and type this in. So 171.4617 0.9882 to the 60. Okay, so we get y equals 84.1120. It does say to round your answer to the nearest whole number. So if we rounded it, we get approximately 84 degrees. That is my final answer. Now let's see if we can use the calculator to see that this estimate, see if it was actually correct. So for the end of 1 hour, so if we look here, the time in minutes only goes up to 50 minutes. So about 60 minutes would be outside. So if you follow the trend, it started at 179 and it went all the way down to 100. So it has to be a little bit smaller than 100. So a time of 60 seconds, it should be something a little bit smaller than 100, which is about 84 degrees, which works perfectly. Okay, part C says use the exponential regression equation found in part A, so the same equation, predict how long, so this time they want us to find the x value to the nearest tenth of a minute, that would take the coffee to reach 138 degrees Fahrenheit, where the temperature is our y. So we're going to go ahead and put the y into 138. And we have 171.4617.9882 to the x power. And this should ring a bell. I know it's been a while since we've done it, but anytime we're asking to find how long, time, you need to be thinking we need to use logs to solve. So the way that we do log equations is we have to first isolate this stuff right here, the base, with this exponent attached to it. So we have to get rid of this 171.46. So what we're going to do is we're going to divide it out. So 171.4617. And it will be, I'm just going to make it a little bit smaller, it will be 0.9882 to the x power on this side. And I'm going to type this in, 138 divided by 171.4616. And I get approximately 0.80484. I don't have to write them all, but that would be the values. And then if you remember, when we solved log equations, we had to log both sides now. So I'm going to log this side. So log of 0.804 ... equals log of 0.9882 to the x power. And then remember, when we have an exponent, we have to drop it like it's hot. So we take the power, drop it in front. So x times log of 0.9882 equals log of all of this. And then to get x by itself, since this is attached by multiplication, we just have to divide the log of 0.9882 on both sides. So if we go into the calculator, we're going to type in log of 0.80484. I'm going to do at least 4 values here. You could hit second answer if you want. Actually, maybe I can do that. That's easier. Log of second answer will give me the answer from before, divided by log of 0.9882, and hit enter. And we get approximately 18.229. So it says to the nearest tenth. So it would be 18.3 minutes would be my final answer. And let's see if this makes sense. So let's go back and we want to look for 138 degrees. So 138 would probably be somewhere around here, right? Between 141 and 134. So between 15 and 18 should be our time in minutes. And we got 18.3. So yeah, pretty close, that works nicely. All right, that's it for exponential regression. If you have any questions, please let us know. Have a good one.